Sipoc is an acronym that stands for Supplier, Input, Process, Output, Customer. Supplier, Input, Process, Output, Customer. So any project that you work on, you must try to understand the stakeholders involved. Stakeholders involved. See here in my slide, what you see is a credit card ordering process. What do you see? Credit card ordering process. See here, the process is visualized. Once you submit your application form for the credit card, when executive from the bank side, they perform the credit check. After the credit check is satisfactory, a credit card will be ordered. And then email confirmation will be sent to you saying that your application is approved and card will be dispatched within 10 days. And then the documents will be filed, the paperwork. All of it, you understand the bigger picture of the process that we are trying to improve? Please confirm. Do you understand the bigger picture of, we say high level process map? Why? Because we only show the few important steps, not the complete detail. We only show the important steps. Order placed, credit check, perform the credit check, then order the credit card detail, then mail confirmation to the client and paperwork. The dispatch process is out of the scope. Can you see that?
Yes.
Because the dispatch is done by an external vendor, maybe some Blue Dot or some company will deliver. That is not brought in the project scope. And now there's some improvement is required somewhere here. And by showing this picture, what is the added information the sponsor is getting? Normally, Sipoc is submitted along with the project charter. What is the added information the sponsor will be getting by going through the Sipoc? Come on.
Mail confirmation letter.
No. Mail confirmation letter. I'm not able to. You are giving your sponsor the clarity that you know the clarity that you have identified the right process that is responsible for the failure. In problem statement, you are saying a metric, right? Metric is Y variable. That metric should be an outcome of this process. That metric should be an outcome of this process. So the sponsor will have confidence that you will use the resources in improving the actual process responsible for the failure. Say, for example, in our training program also, you are attending classes, you are writing, you are going to write the exam, and certificate dispatch will be happening, and one side payment processing also happening, and then the documentation for the certificate. How many process we are dealing right now in this training itself? Documentation for your certification, then delivery of your certification, then conducting examination, conducting your training. Is there any other process? Oh, okay. So 4 only. All right. Now imagine let us say the participants are scoring less marks in the exam. This is the problem. The pain metric is
Less marks.
examination score. Now tell me which of this process I should improve.
Training.
Should I improve the certificate dispatch?
No.
Should I improve the training?
Yes.
Or should I improve the examination process? Or
Yes.
should I improve the documentation process?
Training and examination.
You told me very correctly. Training and the exam. So examination is a process, that is going on well. But in order to improve your performance in the exam, probably we have to improve on the training, isn't it?
Yeah.
So how can we devote more time on the exam related preparation? exam related question. How can we devote more time? Or how can we give more preparatory exam, mock exam? The exam related orientation, the focus has to be increased. So you rightly pointed out, focus on the training. Focus on the training. Exam process is good only. Examination, is conducted. People are writing the exam. Nothing wrong there. The questions are relevant and everything is correct. Well planned. That means the improvement is required only in the training. Your Sipoc should indicate that you are going to improve on the training process. The way in which you conduct the training, you are going to improve. Maybe the duration you might increase, isn't it? So that we will actually analyze. So that is the purpose of Sipoc. Clear, all of you?
Yeah. Where to improve?
So now, yeah. So now let us take another example. The process the project team is trying to improve is pizza preparation and delivery. I'll tell you the background of this. Let's say there is a outlet, pizza outlet running, and the outlet performance is not up to the mark. Majority of the customers are saying that the delivery is, they are taking too much time. Now, what is the customer? What is the pain metric? Come on, what is the pain metric?
Timeline for
Delivery
delivery.
time. Delivery time.
Delivery time. Very good. I like this word, delivery time. Always try to come out with a metric, delivery time. And pizza delivery time. Can one of you, will you be able to define what is pizza delivery time in 2 lines or 3 lines? If anybody reads that definition, they should be able to correctly understand what exactly
From
is
order.
the
Yeah, from
The time
order to
taken.
delivery.
order to
Delivery.
delivery. So the starting point is order.
Yeah.
What is the confirmation that an order is placed? Suppose if you are the pizza
So
outlet
to be
manager,
more specific,
how do
the
you
time
know?
taken from the acceptance of the order till the time when the order is delivered to the customer.
Very good. So Santosh Ram has clearly gave the definition. Time between order acceptance and the delivery of the pizza at the no to the customer. Very good. And there is a problem with the time, isn't it? It's not just one customer who made a complaint. So many complaints are coming. So you studied the last 1 month or 3 months performance. All the delivery time record is available. And you see that on an average, delivery time is 40 minutes. On an average, delivery time is 40 minutes. Your baseline is 40 minutes. And the outlet manager and team, they would like to bring down the delivery time to less than 20 minutes to capture more orders. Because there is another pizza outlet in the same location who are who are able to deliver faster. Now the pain metric is understood. And now the process behind the failure has to be visualized and has to be improved. Am I right?
Right.
Now tell me, in a pizza outlet center, what are all the various processes the manager will be looking after? Raw materials have to be procured.
Payment.
Yes or no? He has to procure the raw material
All the
and
other
there will be some
gas.
invoicing.
Processing time.
Yes, sir.
Processing time.
Processing time. So specifically here, the failure is because of the time consumed by the delivery boy plus the time consumed by the pizza making person. Am I right?
Yeah.
So
Yes, sir.
we are now going to focus on pizza preparation and delivery. And that is what you are seeing here in the form of a Sipoc. What is the first step here? Customer places an order. When the customer places the order, what will be the output? The store receives payment and the store also receives the cooking instruction and delivery instruction. Am I correct?
Yes.
Yeah. Now, who will receive all this information? Maybe the store cashier, right? If you think the store manager will receive, then you can replace here, store manager. If you think Mr. Munusami will receive, you can say Munusami here, no problem. Whatever is really happening, you mention here. All of you agree?
Yes.
And now the store cashier has to take some action. He has to inform the cook and the delivery boy, no, so that they can start doing their work. Yes or no?
Yes.
Now the store cashier becomes the supplier for the next process because he is initiating, isn't it? And now
Yeah.
the process he has to do is he has to transfer the details to the cook
Yeah.
and the delivery boy. So the cooking instruction goes to the cooking expert, who is the chef, and delivery instruction goes to the delivery boy. So the chef and the delivery boy are the customers now. Clear, all of you?
Yes, sir.
Now the supplier is store cash. Now for the next stage, you know what will happen in the next stage? The actual pizza will get cooked. In order to cook the pizza, toppings are required, ingredients are required. The topics and ingredient, who will bring or who will supply? The chef himself can arrange, or if the chef has got an assistant, the assistant can bring. Am I right?
Yes,
Here,
sir.
in my example,
Yes,
there is
sir.
an assistant. So the assistant becomes the supplier. Assistant becomes the supplier. And so the pizza is getting cooked. And now the output is cooked pizza. The cooked pizza now goes to the packing person. Right? Cooked pizza. See, the packing person may again be the cooking assistant, or may again be the chef himself. Am I right? In some outlet, there will be just one person doing everything. But only to differentiate, I use different names here. But in reality, sometimes, all this work might have been performed by chef only. The chef will appear as a supplier for first step and customer for next step. Again, he may become supplier, customer. The idea here is you are trying to visualize all the people who are involved in the process, who are connected to the process, right? And so now the packing person is actually, packing the box. And in order to pack the box, pack the pizza, some packing items and the pizza is required. And the store manager will provide the packing item and the pizza will be brought by the cooking assistant. And now the outcome or the output is the cooked pizza in a boxed condition. And definitely it must now have the invoice and the delivery details in the invoice. All of these things will now go to the delivery boy, will be collected by the delivery boy. Now delivery boy has to deliver it. And now he needs the packed item, a vehicle, probably some GPRS or whatever, so that he can reach the place as early as possible. And now he has to arrange everything for himself. Now he himself acts as the supplier. And then the ordered pizza along with the bill handed over to the person who ordered the customer. Who ordered the pizza. And now the delivery person returns. Can you see the set of activities or the sequence of activities that are happening related to pizza preparation and delivery here? Yes, sir. The process in the current condition is mapped. Now, further investigation, we will do it little later. Where exactly the time consumption is more, where exactly the delay is happening, and what can we do to minimize all that you can think about, and then come out with the solution. That will happen in the future stages. We are right now in the define phase. Now, one of you was saying, no, I will use SMED to reduce the time, and SMED can be of great help right now in this project. Yes, sir, no?
Yes, sir.
Yes.
If the cooking time is too much, then probably
Shortly time.
SMED can definitely help. Yes,
So
Yes.
you can divide into external, internal activities,
yes, sir.
and there are a lot of ideas you might get.
Combine
So
certain
this is the
activities.
purpose of site. Yes, Mr. Santosh.
Combine certain activities while one person is raising the banking interest,
Yeah,
another
yeah,
person check the
correct, correct. You can combine certain activities. You can change certain activities, and thereby the time can drastically come down. All right. And now, can you see all the people involved as suppliers on the left side and customers on the right side? All of them somehow you are going to involve in your project. In general, they will be called as stakeholders. In general, they will be called as stakeholders. Now you also understand their responsibility with respect to the process. Now the roles and responsibility card can be created. Tell me, can you create a roles and responsibility card right now for this process?
Yes.
Very good. The responsibility of the delivery boy, responsibility of the chef, responsibility of the cooking assistant, responsibility of the cashier, responsibility of the billing manager. Everyone responsibility you can create, and you can expect them to follow. So this is the purpose of Sipoc. Now the point is how can you create a Sipoc for your project? You remember for the welding project, the Sipoc is now available here. These steps are related to welding. These steps are related to welding, and you don't have to show all the steps. Always, while creating a Sipoc, show only 5 to 8 important steps, not all. And now, what I expect you all to create a Sipoc diagram also.
Sir, so Sipoc diagram will be useful only for general operations, regular operations, or also for the projects, for projects that we are going to take probably. Say Lean Six Sigma.
Your project only I'm saying. In your project, see, in Six Sigma, our project is nothing but process improvement. Project is nothing but process improvement. And you have to tell clearly the process you are going to improve. What is the process you are going to improve? What is the starting point? What is the ending point? What are the important steps, important activities that are happening? And for each of the activity, what are the inputs needed? And who will supply the input? And each of the activity, what will be the output? And who will receive that output? This piece of information, you should be able to submit along with the project charter.
Okay.
To boost the sponsor's confidence in the ability of the project team. Imagine you give your you want to do a project in your family. You want to do a project in your family. Let's say you want to raise your children in a particular field. In a particular field. So let's say they have to clear a competitive exam, and now you allot a budget for that. Next, no, right now your kids are studying 10th standard because after 12th, they have to join some good college, maybe IIT or IIM or some college. And so, your kids have to prepare them for the competitive exam. Now you allot a budget. All right. The budget is 5 lakhs you allotted. And this 5 lakhs, you are going to give it to your wife. You are going to authorize your wife to decide spending of the 5 lakhs. Will you be interested in knowing that how your wife will spend that 5 lakhs? Yes or no? All of you, are you listening to me
Yes, yes, yes.
continuously?
Yes, sir. Yes,
Yeah,
sir. Yes.
speak to me. Because we have taught you the theory. Now we want to ensure you are actually, have the confidence. You are allotting 5 lakhs budget and you are authorizing your wife to spend the money the way it is required. Once approved, she don't have to come back to you. So now would you like to know where your wife will be putting that money? Now your wife can spend that money for whatever purpose she wants, isn't it? She can take all the, what do you call, the saris and dress materials for the Diwali. or she can use that money for really, putting your son or daughter in some kind of tuition or some kind of institute where the coaching is given, isn't it? So now,
Yes.
where exactly, the money is going? So that means, what kind of process your wife is going to focus on? Yes or no?
Yes.
If you get the gist of, I mean, the overview of the area where your wife is going to pump in the money, and if you see that relevant, then you can actually, you will actually authorize, you will actually approve the project. So that is the purpose Sipoc is doing. Sipoc is letting the sponsor know that you are going to invest that resource in the right process. Clear?
Yes.
That's the
Yes.
idea. So now that, sorry, screen sharing has stopped. So now that completes our discussion on charter and sponsor, I mean, Sipoc. What I expect is, next week when you all come, yeah, like you can divide yourself into two groups, 4 or 5 each, and come with a project charter along with the Sipoc,
Okay.
right?
Yes.
And
Sipoc
we
for
will
the
just
same
discuss
averages
Sipoc.
for the same for the same
Yeah,
project.
yeah, to support the same project. Yes, to support the same project. That's very important. We want to know whether the process is really, connected to the metric. If the process is if the process output is not actually, the metric, then you are working in a wrong process. Finally, our metric has to improve. All right. So with that, we are done with the define phase, and we are now going to talk about the measure phase. Now, tell me, what have you learned in measure phase? What have you learned in measure phase? What is your
Whether a measuring
understanding in
tool
the measure
is
phase?
perfect or not.
Already that has been measuring tool. I mean, we call it measurement system. Whether our measurement system is, first of all, correct or
Perfect or
not, valid. Do we have a appropriate measurement system which can get us error-free data? That's very important.
So, sir,
And
relevant data,
after that, yes, relevant
whether the
data.
measurement
And
is
after
capable,
collecting,
capable or not.
yeah, whether our measurement system is capable or not. So this is called measurement system validation. Once the measurement system is validated, you go with the collection of data, and then you will calculate the baseline. You will calculate the baseline. Let us say the rejection rate. Rejection rate is 5%. But when I actually collect the data for 30 days, I see that the rejection rate is 8.2%. But what was written in the project charter? 5% was written in the project charter. But what is that I am actually noticing? 8.2%. Now, which is correct? 8.2% is correct or 5% is correct?
8.2.
Come on. Yeah, you actually, you collected data now. So data says that
8.2
the rejection rate is 8.2%. But earlier your understanding was very approximate. People told that it is 5%, and so you just documented it. But now you better understand the problem. Now you go back and redefine your project charter, redefine your problem state. All of you understand?
yes, sir.
The purpose of the measure phase is it gives more clarity, it brings more clarity to the problem statement now. Like doctor at the time of admitting the patient have some understanding about the patient health condition. But it is actually after the arrival of the diagnosis report, the doctor gains more clarity about the condition of the patient's body condition, isn't it?
Yeah.
So no. So the same. So, but in the process, your diagnostic system must be accurate. System must be accurate. Your measurement system must be a validated measurement system. And now there are two things you might have learned. One is very important thing is gauge R&R study. Am I right? Gauge R&R study. I'll tell you what is gauge R&R study. Any data that you collect should have two characteristics. One is accuracy, another one is consistency. What are the two things required? Accuracy and consistency. Consistency means whenever you take repeat readings must be consistent. Repeat reading means what? You repeat the same experiment multiple times. See, recurring. Actually, we call it replication. Call it replication. See, you remember in your school days, college days, when you perform an experiment in the laboratory, your teacher always asks you to repeat the experiment 2, 3 times. Yes or no? Teacher will ask you to repeat the experiment 2, 3 times. After repeating the experiment 2, 3 times, what will you do? You find average of it. Yes or no? You will find average of it. That average you will use it in the formula so that you will get more accurate result. Because teacher know when you do the experiment just once, there is a chance of experimental error. In order to minimize the experimental error, teacher will ask you to do the same experiment 3 times and use the average of the 3 values. Do you think this approach is really helpful?
Yes, sir.
Yes or no?
Yes, yes.
Yeah, that will minimize the bias. Please understand that will minimize the bias. Now, when as per the teacher's instruction, when you are repeating the experiment 3 times, all 3 times you must follow the same procedure. Yes or no?
Correct, sir.
If you follow the same procedure, then you must get same reading. Correct? This is known as consistency. This is known as consistency. But if you don't get same reading, if you get different reading, this is known as inconsistency. The inconsistency in your reading is known as precision error. Do you understand, all of you? The inconsistency in your reading is known as precision error. Now let us do a small exercise and try to understand this precision error. So if you are not consistent, then you cannot be accurate. All of you agree with me? If you cannot produce consistent reading, then you cannot produce accurate reading. So finally, to understand whether you are accurate or not, we calculate something known as bias. We calculate a value known as bias. So what is the definition of bias? The difference between true value and the measured value. The difference between true value and the measured value. So ultimately, the bias in your reading should be less than 10% of, should be less than 10% of the working range. The bias, how much is the permissible bias? 10% of the working range or 10% of the tolerance. This is the guideline. And now let's please note, resolution of a measuring instrument means least count. Resolution means least count. Nothing but the lowest reading that can come from your measuring instrument. In the mobile phone, the stopwatch, what is the lowest reading that can come? 0.01 second. And 0.01 second is not millisecond. Millisecond means 0.001 second.
1001.
Clear? Let us not use the word millisecond to be on the safer side. Let's say the least count or the resolution of the stopwatch in our hand is 0.01 second. Always when your team is collecting data, all the team member must collect the data in the same manner. Is that correct? Isn't it? All the team member must collect the data in the same manner, and all of them must use the same unit of measurement. If one person is measuring in seconds, then everybody should measure in seconds only. Minutes means minutes. Hour means hours. Now, right now, I want all of you to measure in terms of seconds. Clear? I'll give a task. You all are going to measure the duration.
Chairman.
There is some variation. This is known as measurement variation. This is known as inconsistency in the measurement. All of you measure the duration of the same song. Same song has been played, but for some reasons, because you all don't hit the button at the right time, there is some time it takes. No, so there is a variation. You can't, completely eliminate that. It is not possible, right? Maybe the manual component you have to minimize to achieve the consistency. And now this is known as error due to inconsistency. Error due to inconsistency, and we call it as precision error. We call it as precision error. Now, near about 8 people are involved in the data collection. Am I right? Each one of you collected the data. And you are not able to, your readings are not agreeing to the other's reading. This error is known as reproducibility error. Do you understand? The reading
So can you
produced by
please
Santosh. Yes.
Can you
Come on,
please repeat
Santosh.
what was that error called?
The reading produced by one appraiser, others are not able to produce. If there are multiple appraisers involved, if they are not agreeing to each other, the error is known as reproducibility error. Got it? Please note, this may not be a serious issue. This may not be a serious issue in all projects, but in certain project where you are trying to validate the small differences, this will become a serious issue. Am I right or not? Right? So wherever you understand, even a small difference is going to be a serious issue, your measurement system must get validated. The precision error should be brought under control. One form of precision error is reproducibility error. All of you understand? Reproducibility error happens if multiple appraisers are involved. And now if I play the same song one more time for the same duration, do you think all of you will get the same reading?
No, sir.
No.
That means even though you measure the same thing for the second time, you yourself know that your second reading can be different from first reading. Now both readings are produced by the same appraiser, but still there is a difference. This is known as repeatability error. Do you understand? If the readings of the, I mean, if there is inconsistency in the readings of a single appraiser, it is known as repeatability error. Do you understand, all of you? There is one format known as repeatability error and another format known as reproducibility error. Correct?
Sir, so if we can define, repeatability is within the same person and
Yeah, within the
reproducibility is
same
in the group.
person, same measurement system. Same measurement system is used to measure the same characteristics 2 times, but first time he gives one reading, second time he gives another reading. Now the error should be called as repeatability error. Clear?
And reproducibility is within the group.
Reproducibility means multiple measurement system are used, multiple data collectors, multiple appraisers.
Okay.
And please note, reproducibility error and repeatability error. They are in general called as precision error. In general called as precision error. Precision error might refer to repeatability error or might refer to reproducibility error. Clear, all of you? So the exact definition of precision error is repeatability error plus reproducibility error. So what is precision error? Precision error is sum of repeatability error and
Sum of reproducibility.
reproducibility error. All of you understand the definition for precision error? You have to
Sum of
combine the repeatability error and reproducibility error. Sum up. After summing up, you just check. You just divide the error by the tolerance provided by the customer. You divide the error by the tolerance provided by the customer. So the numerator is what? Precision error. Denominator is tolerance. The precision tolerance ratio is known as gauge R&R. How many of you understand what is gauge R&R? All of you, right?
yes,
I'll
yes.
show you the slides. I'll show you the slides so that you can better
No, sir, I
understand.
don't understand the gauge and RNR.
Yeah, I'll show the slides. Now you will understand. So can you see my slide now?
No.
No, sir. Yes, sir.
Now, right? See here, precision error is sum of repeatability error plus reproducibility error. This is clear?
Yes.
Very good. Now, the precision error is compared against the working range or the tolerance provided by the customer. Why? To estimate the gauge R&R. So, gauge R&R means precision error divided by tolerance. Precision error divided by tolerance is always difference between USL and LSL. Right? Can you see a ratio here? Precision in the numerator, denominator is tolerance.
Tolerance.
The precision tolerance ratio is known as gauge R&R, where R&R stands for repeatability and reproducibility error. All of you understand what is gauge R&R now?
Yes.
Please confirm.
Yes, sir.
Very good. And now, if this gauge R&R value, if it is less than 10%, your measurement system is considered a good measurement system and accepted for data collection. But if the gauge R&R value is in the range of 10 to 30%, measurement system is considered conditionally acceptable. Conditionally acceptable. But in any case, if it is more than 30%, not acceptable. This is called measurement system validation procedure. You must calculate gauge R&R and that value must be less than 10%. Any doubts, any questions on gauge R&R? Once
No,
the
sir.
gauge R&R is calculated, if it is found to be less than 10%, now you can actually collect data. Maybe if needed, you can also check the bias, calibrate the equipment, and then collect the data. Now, what will I
What is the
do?
meaning of the word gauge here?
Meaning of the word gauge means it's a measuring instrument. That's all.
Repeatability and reproducibility.
No,
No,
gauge
RNR.
actually refers to the gauge only. But
Because
R&R refers to
RNR we understand is repeatability and reproducibility.
ah,
But what is gauge over here? Does it also have some,
gauge
is it an
refers to
acronym?
the measurement system. Gauge refers to the measurement system.
Gauge is checking aid.
Yeah, the instrument you are using, But actually, though we say instrument, it is actually the system. An instrument, the data collector, the characteristics that you are measuring, the instruction that you give it to the data collector, the environment under which he is collecting the data, all of them are element inside your measurement system. Do you understand? All of these things are elements of the measurement system, and all together is known as measurement system. And we simply call it as the gauge R&R. All right. So let me share the Minitab screen and let me show how you can calculate the gauge R&R using Minitab. And then we can wind up once we learn this. All of you, can you see my Minitab screen?
Yes.
This is
Yes,
a
sir.
Minitab software. Did I post the link of the Minitab software? Yes, already posted, right?
No, no.
Okay.
Couldn't post
And today,
it, it just suggested us to download the trial version.
yeah, you have to download and then install in your computer. And if you have the permission to install, please install, right? And today I posted some mock exam link in the appropriate groups, in your WhatsApp groups. I suggest all of you to try the mock exam to test your understanding in the define phase. Once you finish the measure, take the measure phase exam, then analyze, then improve control. And also there is also a mock exam, paid mock exam also available. If you are interested, you can take that. And so that you can perform well in the exam. All right. See, now I'm showing you the Minitab screen. This area of the Minitab screen where I am currently moving the cursor, this is known as worksheet. You remember, all of you?
Yes.
This is known as worksheet. And this area where I'm typing right now, this is session window. And now I want you to open a data file. See here, go to stat, quality tools, come to gauge study. Stat quality tool, come to gauge study. Then you come to create gauge R&R study worksheet. Stat quality tools, gauge study, gauge R&R study worksheet. You click that. After clicking, this window comes. Now Minitab is asking you how many parts you are going to study. I just played one song for the exercise. Am I right? Actually, always any exercise you do, there must be at least 10 parts. I should have played 10 different songs to have a proper demonstration of the gauge R&R study. But when I play 10 songs, then the time will be, 12 o'clock midnight. So that's why I didn't do that. So, but in your project, when you do a gauge R&R study, how many sample parts you must select? 10
Minimum 10.
parts.
Okay.
The 10 parts
Sir, it's
should
minimum
cover
10 or
10,
10 is
10, 1 0.
Minimum 10.
Minimum 10. Yes, you're right. Minimum 10. Another condition to get satisfied is the sample should cover the entire tolerance. Samples should cover the entire tolerance. What are the extreme limits? Upper specification limit, lower specification limit. You must cover the entire tolerance. In such a manner only you must select the sample. All of you, do you understand?
Yes.
Very good. Let us say 100 mm plus or minus 0.5. What is the upper spec? 100.5. Lower spec 99.5. Now you must take 10 parts between 99.5 and 100.5. Right? 99.5, 99.6, 99.7. In this manner you have to take. Perfect?
Yes.
Now, how many people are involved in the data collection? In some projects, only two members. In some project, it is 3 members. So 2 or 3. If you want to have 4, for reasons, you can have 4. Otherwise, 3 is good. Clear, all of you? And
Yeah.
you can also declare the name. Let's say I want to declare your name only. First data collector is Santosh. The second data collector is Sujit. And the third data collector is Sambandham. All right. Now data collector's name also given. Now part number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now each experiment, how many times you want to do, that is known as replication. If you are not replicating, you will not be able to understand the repeatability error. All of you understand? So you must replicate at least twice. If possible, replicate thrice. Then 10 parts, 3 operators, 3 replication. 10 into 3 into 3, how much? 90.
20.
90 readings are required now to calculate the gauge R&R study. Right? I give okay. Now, can you see the gauge R&R worksheet getting generated with the 90 rows? Can you see?
Yes.
Every row represents one experiment. And now in the column number 4, you can actually have the measurement. Whatever it is, whether you are measuring temperature or measuring pressure or measuring strength or measuring the cycle time, whatever you are measuring, first reading will come from Santosh. Santosh will measure the 9th part and give me the reading. Whatever is the reading, 43.56 somewhere, some reading he gives. Now Santosh will go to 4th part and make the measurement. He'll give again, some reading, whatever reading he gives. In this manner, I have to conduct the exercise. This is called randomizing the trials. After Santosh, Sujit comes. After Sujit, Samandan comes. Again, Santosh goes. Again, Sujit goes. Again, Samandan goes. But the order in which they measure is not revealed to them in advance. Please note. Is not revealed to them in advance. Why? We want to avoid the bias in the reading. If you tell them that they are going to measure each part 2 times, they might measure once and put 2 and fill up two rows, isn't it? So we wanted to avoid. Now, after generating 90 readings, you can do some max to know the gauge R&R value. If the gauge R&R value is less than 10%, you should be extremely happy about your measurement system. So what is our measurement system here? The operators involved, the instruction involved, the 10 parts involved, all right, and the environment under which you make the measurement, and all of these things together is known as measurement system. Now let me take a sample data. For that purpose, I go to File, I go to Open Worksheet. Now I click this green color icon once, and then I type gauge here. So I can get this, I can see this file name. What is this file name? Gauge AIAG. I click that and then say open. And again, I give open. So now I have a sample data. Can you see here, all of you? Similar to that 90 data. And now the only difference is, instead of doing the experiment, already the data is stored inbuilt in Minitab. I have opened it so that I can demonstrate how you can do the calculation in Minitab. So I want you to go to Stat, go to Quality Tools, come to Gauge Study, but this time you don't have to create the worksheet. Rather, you go to Gauge R&R Study crossed. Why do I say crossed? Same experiment, same part is used by all the operators. Do you understand? Santosh also measured part number 1. Sujit also measured the same part. Some of them also measured the same part. Because all of you are in the same place. The gauge R&R study is happening in a crossed manner. So I click that. Then this window comes. Now it is asking you, where is your part number? Where is your part number available? C1. Am I right? I feed this information. Now, where is the operator information available? C2.
C2.
Where is the measurement data available?
C3.
C3. Then you can choose between the convenient method. There are 2 methods. This is quite simpler. So choose the simpler method, which is X bar R method. Now you go to option. In the option, you must declare lower spec and upper spec. You must declare lower spec and upper spec. If you don't know the upper spec and lower spec, at least if you know the difference between them, that is also enough. Either because that is the tolerance. We are interested in knowing the range of the tolerance. Let me say the upper spec minus lower spec is 12. When customer has given you this much tolerance, what is your error in comparison to the tolerance? This is the question now. Now, if I say, okay, Minitab will do all the job for me, you don't have to break your head. Right? Minitab has generated a report, initially a graph, but go to the session window. Go to the session window. You see here, gauge R&R method. There is a table, first table. I want you to skip this table, come to the second table. This is the second table. Now in the second table, look at the first row after the heading. Now please tell me, one of you, What is the last column indicate? Percentage
15.29.
tolerance. 15.29.
The system is
And the
good.
requirement, the industry standard is it must be less than 10%. The 15.29 is nothing but total gauge R&R. Am I right?
Yes.
Can you see total gauge R&R on the left side, first column?
Yeah.
The gauge R&R value is 15.29%, which means the measurement
Conditionally.
system is
Conditionally
conditionally.
good.
Conditionally good.
So sometimes it is good to proceed even with 15%. But 10% means less than 10% means your measurement system is too good. Right? Suppose if the customer reduces the tolerance, then the error rate will be more. Please understand. If the customer increase the tolerance, the error rate will be much smaller than. Let me do that for you. Go to stat. Can somebody guide me? Where should I go now after stat?
Quality tools.
After that,
Gauge on gauge study.
gauge
Case
study.
study.
After that,
Gauge on crashed.
very good. And now I feed all the same information. Only thing is in the option, I'm going to increase. Instead of 12, I'm going to make
15.
it,
15.
16, 15 or 16. And now the customer has given a wider tolerance. When the tolerance is wider, maybe the same gauge, will become better now. Now I give okay. I now take you here. Now look at your gauge R&R value. Is 11.4.
2.1.
Instead of having a wider tolerance, if the customer gives a very narrow tolerance, let's see what happens. Stat, quality tools, gauge steady, and then gauge R&R steady crossed. Going to option instead of 16. Now customer gives very narrow tolerance. In that case, definitely your measurement system will not be the apt one, isn't it? So I give okay and I give one more okay. And one more graph has come, but now you go here. Look at your gauge R&R value.
2.8.
It is still in the same scenario, but at the higher side, 22.93, conditionally acceptable. But a measurement system is considered really good and capable if the gauge R&R value is lesser than 10%. All that you need to do is generate readings. This is a pilot reading. Please note, this is not the real data collection. Do you understand? What are we doing now? Pilot data collection. This is not the actual data collection. The pilot data collection of 90 readings we collected and we feed it in the Minitab, and that will tell us whether the gauge R&R is okay or not. And what is okay? Less than 10% is okay. Clear, all of you? Any questions? Please
How to
note
take that? So how to take that examples in Minitab? Just to
how to
explain.
take that example. And anybody have installed Minitab?
I have that.
You have installed, right?
Yeah.
Can you share the screen then? You can do it right now. You open the Minitab in your computer and then share the screen. Whatever I did, now you can do. Please note, we have to do this exercise when the differences are very small. Isn't it? When you are dealing with data, and if the difference is too small, and you might have a doubt that the difference can be because of the measurement error. Definitely under such scenario, you must perform the study. If the differences are too high, then no need to worry. You have a green button, a green arrow button in the bottom.
Yeah.
Please click that green upward arrow button, then share the complete screen. Then you open the Minitab, or if you already opened it, it will be visible. Yeah. So now yours is, I think, Minitab 19. Am I right?
Yes, sir.
Okay, 19 means you must have internet to see all the data. Without internet, it will not work. So go to file. Not
Yes.
file, not file. Go to stat, go to stat. In your case, go to stat, stat, stat.
Yeah.
No, stat means, yeah, the tab, fifth tab, stat.
So you can follow.
File, edit, data, calculate, then stat. Now come to quality tools.
Yeah, that is okay, sir. I'm talking about examples. That's why I'm taking notes.
That's what I'm taking you because your version is different. The procedure is
Yes.
also different. Now you go to gauge study.
Yes.
Go to gauge study, R&R study cross. You click that.
Yes.
And now can you see a help button?
Sorry?
Help button. Can you see a help button?
Yeah, yeah.
Press that.
Yes.
That will open another window for you.
The
Are you
minute
able to
of 20.
see?
Yeah. Enter classification.
Minute of 21. That's what it is, latest version. If you press
Yeah,
the help,
example.
it will open another.
Example is there.
But problem now is we are not able to see your screen. Still only the old screen is visible. You have to share your complete screen, not the Minitab window. So stop sharing, share your entire screen. Then only we will be able to see that example and all. Do you understand?
Yeah, I understand.
So please stop sharing and reshare with you choose the option entire screen. You can stop sharing first. No, not this. No, you don't have to close. You stop sharing your screen. Stop share, you will be able to see, right?
That is-
Screen sharing stop stop sharing in மேல காட்டும் ஒரு option. If you move or curve cursor to the top portion of your
பண்ணிட்டேன்.
now you share again, but when you share again, please make sure you choose the entire screen option. And in the மாதிரி share பண்ணணும். You have to share like this. The advantage is when I minimize this, you will be able to see this. Clear?
Yes, yes.
Share the full screen. Then all the windows I can see going, any new window opening, everything I can watch. Reshare your screen.
Now it is.
Now you click the help button. Click the help button. Help button is there in the bottom. Yeah. Now I can see, isn't it? And
Yeah.
now you scroll down. Or left side, can you see example? No. Just go up. Can you see example? Click that.
Yeah.
And now,
Here is there.
1 minute. This is gauge data. Okay, you can use that example. Click that. Now example data has downloaded. Can you see?
Yeah.
Now you open the data. Yes, you opened it. Now you open the data. With this, you can
Yes.
now you have data.
Yeah.
Got it, Mr. Samandam? Now
Yes, sir.
find out how many data you have. You have 90 data. How many rows of data you have? Just check.
90,
Quick check.
90,
Yeah,
90.
90.
90, yes.
Yeah, now you perform the analysis. Go to stat. You do it. Perform the analysis. Go to stat. Go to quality tools. Go to gauge study and gauge R&R study crossed.
Sir, I have a doubt. Sir,
Now let him finish. No, what happened?
okay, sir.
Quality
Let him
tools,
finish.
gauge study. Yeah. You just park your question. We'll definitely take it. Part number, operator, and then measurement, and choose X bar R, and go to options. Go to option.
Yeah, option is.
You have to declare upper spec and lower spec. Always, when you are actually performing the exercise, you will know the upper spec, lower spec. Now you give rough value, some kind of difference. Yeah. Now you give okay. Now you give one more okay. Now the graph is to find out the root cause of the error.
Yeah.
The graph is to find out the root cause. Now go to the second table.
Sound okay.
Come down, come down. Come down or go
15.2.
up? I think go up. Now come down, yes.
15.29.
15.29 is the gauge R&R value.
Yeah.
There are a lot of calculation happening in the background. You don't have to worry right now. Use this tool, right?
Okay.
And manually
Yes.
doing it will be very laborious and you don't have to go through that struggle. Yes, Santosh,
Yeah.
what is your question now?
Sir, now we had tried to download some example which was already available in online, right, sir? So how is
Correct.
that also giving exactly 90 measurement data? Is it inbuilt or did it refer to what we are given? Okay, sir.
No. It is inbuilt only. If the replications are changed to 2, then it will be 10 into 3 into 2. 10 into 3 into 2 is 60 data. If the replications are defined as 3 and operators are 3, and with the 10 parts, 10 into 3 into 3 will be 90. So 90 is a good number. Please note, we are only estimating the error. What is the actual error? We don't know. If you want your estimate to be, more accurate, then at least 90 reading is a good idea. That is the point. If you take only very less reading, let's say 30 data only, and then your estimation may not be accurate.
I
So
remember
statistics is dealing with accuracy and inaccuracy. Always you should be careful about the accuracy. Otherwise, statistics can mislead you. Correct. Okay, any other question?
Yeah.
Now that you have found a way to create a gauge R&R study report, if it is less than 10%, be happy about it. And then, you can proceed with the data collection. That means you have a good team, good measuring instrument in place to help you in the project. If it is less than 10%. Understand? If all of you write the exam very well, I still give fail mark to all of you. Is it okay? Are we on a right project?
Sir.
No. So that's not a good scenario. If that is happening, we must definitely validate the measurement system. Whenever you doubt your measurement system, you must validate it. How can you validate? Give me five test papers where the students have performed well. Now I must pass all 5 students, isn't it? Because all 5 you gave me good students. Suppose you give 5 poor performing students paper, then I must fail all 5. If I don't do this job perfectly, that's an evidence that the measurement system is not up to the mark. This is what Minitab is doing actually. This is what Minitab is doing actually. And it is calculating the percentage chance of error. When it says 15%, there is 15% probability is there for your decisions to go wrong because of the poor measurement. How much chance is there? 15% means 15% chance is there for your decision to go wrong because of the poor measurement. All right. So the guideline is less than 10%. If you can bring it well below 10%, that is very much appreciable. Now, after doing this, you proceed with the data collection and then use that data to calculate your CPCPK, to calculate your yield, to calculate your DPMO, whatever you calculate, that will be valid. Clear, all of you? Suppose in your project, you have no doubt about the measurement system. Like you all trust our measurement system right now. Yes or no? You all trust that we'll give you the fair marks, correct marks only. Whenever you don't have any doubt about the measurement system, you don't have to, you can skip the step of validation, measurement system validation. Clear, all of you?
Yes.
But if a doubt exists, get it validated. Okay, its time is also a concern. So we'll stop here and then we'll meet tomorrow. All right.
Thank you. Thank you, sir. Thank you.
Thank you, sir.
Hope you
Thank you,
learned
sir.
some
Good
good
session,
tools
sir.
today,
Thank you,
and
sir.
we'll
Thank you,
discuss
sir.
tomorrow. Thank you. Bye.